A lot of statistical analysis is based on samples from some larger group. For example, here is a list of numbers representing data from every member of such a group, not just from a sample, assigned here as the value of a variable population data. There are 10,000 numbers in this list. The random sample function can be used to draw a random sample from that list. This shows random sample giving a sample of 100 values from the value of population data. In statistics, the group from which this data was collected is called the population. The persons or events or items or other entities in that population are referred to generically as individuals, and data collected for every individual in a population is called a census. The value of population data, for example, is a census. This particular census assumes some hypothetical population of 10,000 individuals from which data has been collected, but in practical examples the population may be variable or unlimited or abstract, like all bank transactions or all drops of water or all earthquakes, or it may for some reason simply be difficult or impossible to collect data for every individual in the population. The example considered here involves imagining data for every individual in some limited and well-defined population, but in practical examples it's usually necessary to get information from samples, such as the sample returned by the random sample function. A key question about this or any other sample is, how well does that sample represent the entire population? One way of answering that question is by comparing a histogram of the data from the population with a histogram of the sample. Here is a histogram for the data from the population, and here is a histogram of a sample from that data. A value of the plot range option is included in these inputs so that the histograms use the same horizontal scale, which makes it easier to compare the histograms. The histogram of the sample does differ from the histogram of data from the population, especially in details, but the broad shapes of the two histograms are actually quite similar. Both histograms show data values ranging from 0 to 18, and both histograms show values concentrated in roughly similar regions near the center of that range. It is important to keep in mind, of course, that the histogram of the sample will be different for every sample. If the input that generated that histogram is evaluated over and over and over, for example, each evaluation will generate a different random sample and a different histogram. The histograms differ in details, but all of these histograms, or at least most of them, show the same general similarity to the histogram of the population. Visually comparing histograms, however, and observing that they are sort of similar does not give an especially precise answer to the question of whether a sample is a good representation of a population. The next step will be to work out more quantitative answers to that question.